So this is my simple setup for Regen testing, regenerative acceleration. If you want to study the phenomena of regenerative acceleration, which is accelerating this wheel under load, generate a coil around the wheel. When that's under load, it creates acceleration, okay? Now all you need is a battery to power a DC motor. It's under the tape there. And a wheel with magnets, north-south, all around, evenly spaced. And a coil, high impedance coil ideally, but you just need to experiment and watch the effects of different wire thicknesses, thick, thin, you know. Ideally just get quite a lot of wire, thinnish wire, high impedance, and do some tests. This spins about 8,000 RPM. I think the motor's rated for 10,000. It basically died yesterday. I don't know if I've overpowered it with that battery. It's just a direct connection. If you know why these DC motors maybe just die instantly, let me know if it's an easy fix or if it's not, because I don't know what's wrong with it. It just stopped working. But yeah, it was spinning about 8,000, 9,000 RPM, and I do get a small amount of acceleration when this coil is loaded, and it's just bridge rectifier to a load, lights, 3 12-volt 1 watt lights. Now yesterday when it was spinning, those lights were extremely bright, almost too bright to look at. So this is a very simple setup that you can do yourself to study regenerative acceleration. Now that is generating energy off spinning magnets and accelerating the wheel at the same time, which, according to Thane C. Hines, reduces the current draw on the prime source. Right? So we generate energy and we draw less energy from the source. You can have, I could obviously have a lot of these around this wheel. So that would be generating a lot of energy. And each one gives a bit of acceleration to the wheel. And the other thing, this wheel is quite big compared to the motor, which is about that, like that. If you have a big wheel, when you have these magnets, this mass around the edge, it creates centrifugal forces, and the wheel wants to spin. It really wants to spin. It's very, very advantageous to have a big wheel, I would say, because it creates its own momentum. And even when you disconnect the battery, you're still generating energy. Like, these lights will stay on for quite a while this runs down. Under its own momentum, it is generating energy without being connected to the battery. So the centrifugal forces of the mass around this wheel is really, really amazing, really. You know, that is straight up free energy without any question. So having this mass in this large wheel, you got that momentum, the centrifugal forces, it wants to spin. If you have a small wheel like this, it will, when I disconnect the battery, it will stop almost immediately. No free energy. It has hardly got any of its own momentum. It's more like centripetal. It just wants to stop when you stop powering it. But this one goes for quite a while. And these stay on very bright. They start to dim, obviously, after a certain amount of time. But you definitely get free energy when you got a big wheel like this. And that's very, very simple to understand. Just the simplicity of large diameter and mass. You know, the momentum is free energy. And obviously you can pulse the motor on and off. So there we go. But if you want to do Regen tests, that's all you got to do. Spin magnets north south alternating, spin them on a wheel, have a coil aligned to where the magnet is. Yeah, so have it aligned fairly well, and then just do some measurements. Simple. Connect a bridge rectifier to the coil and then a load. Now I don't know if bridge rectifier is necessary, but we have got AC, so you'd have to either have a direct AC load or do a bridge rectifier, do a DC load. Yeah, and this is very simple. This is extremely simple, right? And these kind of generators, it could be made all over the world, and we could have a situation of extremely efficient use of energy. Right? So yeah, I can't run it because the motor's died. I'm going to buy a new one. If you're any geniuses out there can tell me why it's died, let me know. But I guess I'm just going to buy a new one. And I'm going to put together another pulse motor today. So, but yeah, thanks for watching. Feel free to do your own tests, because, you know, we just got to develop this as a community, I think. Right, thank you.